1. How to write the materials and methods section. The greatest invention of the 19th century was the invention of the method of invention. A.N. Whitehead. Purpose of the section. In the first section of the paper, the introduction, you should have stated the methodology employed in the study. If necessary, you also defended the reasons for your choice of a particular method over competing methods. Now, in materials and methods, also designated in some cases by other names, such as experimental procedures, you must give the full details. Most of this section should be written in the past tense. The main purpose of the materials and methods section is to describe, and if necessary, defend, the experimental design and then provide enough detail so that a competent worker can repeat the experiments. Other purposes include providing information that will let readers judge the appropriateness of the experimental methods, and thus the probable validity of the findings, and that will permit assessment of the extent to which the results can be generalized. Many, probably most, readers of your paper will skip this section, because they already know from the introduction the general methods you use, and they probably have no interest in the experimental detail. However, careful writing of this section is critically important because the cornerstone of the scientific method requires that your results, to be of scientific merit, must be reproducible, and, for the results to be adjudged reproducible, you must provide the basis for repetition of the experiments by others. That experiments are unlikely to be reproduced is beside the point. The potential for reproducing the same or similar results must exist, or your paper does not represent good science. When your paper is subjected to peer review, a good reviewer will read the materials and methods section carefully. If there is serious doubt that your experiments could be repeated, the reviewer will recommend rejection of your manuscript no matter how inspiring your results. Materials for materials include the exact technical specifications, quantities, and source or method of preparation. Sometimes it is even necessary to list pertinent chemical and physical properties of the reagents used. In general, avoid the use of trade names. Use of generic or chemical names is usually preferred. This approach avoids the advertising inherent in the trade name. Besides, the non-proprietary name is likely to be known throughout the world, whereas the proprietary name may be known only in the country of origin. However, if there are known differences among proprietary products, and if these differences might be critical, then use of the trade name, plus the name of the manufacturer, is essential. When using trade names, which are usually 280, location 1529 of 7487 registered trademarks, capitalize them, Teflon. For example, to distinguish them from generic names. Normally, the generic description should immediately follow the trademark. For example, one would refer to Kleenex facial tissues. In general, it is not necessary to include trademark symbols, such as registered in T. However, some journals ask authors to do so. Experimental animals, plants, and microorganisms should be identified accurately, usually by genus, species, and strain designations. Sources should be listed and special characteristics, age, sex, and genetic and physiological status, described. If human subjects were used, the criteria for selection should be described, and an informed consent statement should be included in the manuscript. Likewise, if human or animal subjects were used, approval by the appropriate committee should be noted, because the value of your paper, and your reputation, can be damaged if your results are not reproducible. You must describe research materials with great care. Examine the instructions to authors of the journal to which you plan to submit the manuscript, because important specifics are often detailed there. Below is a carefully worded statement applying to cell lines and reagents. It is taken from the Information for Authors of In Vitro Cellular and Developmental Biology Animal, known for short as In Vitro Animal, a journal of the Society for In Vitro Biology. The source of cells utilized, species, sex, strain, race, age of donor, and whether primary or established should be clearly indicated. The name, city, and state or country of the source of reagents should be stated within parentheses when first cited. Specific tests used for verification of cell lines and novel reagents should be identified. Specific tests for the presence of mycoplasmal contamination of cell lines are recommended. If these tests were not performed, this fact should be clearly stated. Other data relating to unique biological, biochemical, and/or immunological markers should also be included if available. Publication of results in vitro animal is based on the principle that results must be verifiable. Authors are expected to make unique reagents available to qualified investigators. Authors deriving or using cell lines are encouraged to follow the United Kingdom Coordinating Committee on Cancer Research guidelines for the use of cell lines in cancer research in respect to validation of identity and infection-free cultures. Methods. For methods, the usual order of presentation is chronological. Obviously, however, related methods should be described together, and straight chronological order cannot always be followed. For example, even if a particular assay was not done until late in the research, the assay method should be described along with the other assay methods, not by itself in a later part of the Materials and Methods section. Headings. The Materials and Methods section often has subheadings. To see whether subheadings would indeed be suitable and, if so, what types are likely to be appropriate, look at analogous papers in your target journal. When possible, construct subheadings that match those to be used in the Results section. The writing of both sections will be easier if you strive for internal consistency, and the reader will be able to grasp quickly the relationship of a particular method to the related results. Measurements and analysis. Be precise. Methods are similar to cookbook recipes. If a reaction mixture was heated, give the temperature. Questions such as how and how much should be precisely answered by the author and not left for the reviewer or the reader to puzzle over. Statistical analyses are often necessary, but your paper should emphasize the data, not the statistics. Generally, a lengthy description of statistical methods indicates that the writer has recently acquired this information and believes that the readers need similar enlightenment. Ordinary statistical methods generally should be used without comment. Advanced or unusual methods may require a literature citation. In some fields, statistical methods or statistical software customarily is identified at the end of the Materials and Methods section. And again, be careful of your syntax. A recent manuscript described what could be called a disappearing method. The author stated, the radioactivity in the turnout region was determined by the trichloroacetic acid soluble method of Britton et al. And then there is the painful method. After standing in boiling water for an hour, examine the flask. Need for references in describing the methods of the investigations. You should give, or direct readers to sufficient details so that a competent worker could repeat the experiments. If your method is new, unpublished, you must provide all of the needed detail. If, however, the method has been published in a journal, the literature reference should be given. For a method well known to readers, only the literature reference is needed. For a method with which readers might not be familiar, a few words of description tends to be worth adding, especially if the journal in which the method was described might not be readily accessible. 68. If several alternative methods are commonly employed, it is useful to identify your method briefly as well as to cite the reference. For example, it is better to state cells were broken by ultrasonic treatment as previously described. 9. than to state the cells were broken as previously described. 9. Tables and figures. When many microbial strains or mutants are used in a study, prepare strain tables identifying the source and properties of mutants, bacteriophages, plasmids, etc. The properties of multiple chemical compounds can also be presented in tabular form, often to the benefit of both the author and the reader. Tables can be used for other such types of information, a method, strain, or the like used in only one of several experiments reported in the paper can sometimes be described in the results section. If the description is brief enough, it may be included in a table footnote or figure legend if the journal allows. Figures also can aid in presenting methods. Examples include flowcharts of experimental protocols and diagrams of experimental apparatus. Correct form and grammar. Do not make the common error of including some of the results in this section. There is only one rule for a properly written materials and methods section. Enough information must be given so that the experiments could be reproduced by a competent colleague. A good test, by the way, and a good way to avoid rejection of your manuscript, is to give a copy of your finished manuscript to a colleague and ask if he or she can follow the methodology. It is quite possible that in reading about your materials and methods, your colleague will pick up a glaring error you missed simply because you were too close to the work. For example, you might have described your distillation apparatus, procedure, and products with infinite care but then neglected to define the starting material or to state the distillation temperature. Mistakes in grammar and punctuation are not always serious. The meaning of general concepts, as expressed in the introduction and discussion, can often survive a bit of linguistic mayhem in materials and methods. However, exact and specific items are being dealt with and precise use of English is a must. Even a missing comma can cause havoc, as in this sentence. Employing a straight platinum wire rabbit, sheep and human blood agar plates were inoculated. That sentence was in trouble right from the start because the first word is a dangling participle. Comprehension was not totally lost, however, until the author neglected to put a comma after wire. Authors often are advised, quite rightly, to minimize use of passive voice. However, in the materials and methods section as in the current paragraph, passive voice often can validly be used, for although what was done must be specified, who did it is often irrelevant. Thus, you may write, for example, mice were injected with, rather than I injected the mice with, a technician injected the mice with, or a student injected the mice with. Alternatively, you may say, for example, we injected, even if a single member of the team did that part of the work. Although belief persists that journals prohibit use of first person, many journals permit use of I and we, because the materials and methods section usually gives short, discrete bits of information. The writing sometimes becomes telescopic. Details essential to the meaning may then be omitted. The most common error is to state the action without, when necessary, stating the agent of the action in the sentence to determine its respiratory quotient. The organism was. The only stated agent of the action is the organism, and we doubt that the organism was capable of making such a determination. Here is a similar sentence. Having completed the study, the bacteria were of no further interest. Again, we doubt that the bacteria completed the study. If they did, their lack of further interest was certainly an act of ingratitude. Blood samples were taken from 48 informed and consenting patients. The subjects ranged in age from 6 months to 22 years. Pediatric. Rees. 626, 1972. There is no grammatical problem with this sentence, but the telescopic writing leaves the reader wondering just how the 6-month-old infants gave their informed consent. And, of course, always watch for spelling errors, both in the manuscript and in the proofs. We are not astronomers. but we suspect that a word is misspelled in the following sentence. We rely on theatrical calculations to give the lifetime of a star on the main sequence. Anu. Reverend Astron. Astrophys. 1 to 100. 1963. Although they might have been done with a flourish. Presumably the calculations were theoretical, not theatrical. Be aware that a spellchecker can introduce such errors and therefore cannot substitute for careful proofreading. One recent example. A spellchecker's conversion of pacemakers and dogs to peacemakers and dogs. We have known some dogs that could benefit from peacemakers, but we rightly suspected that this wording was not intended in writing about canine cardiology. To how to write the results. Why, man, I have gotten a lot of results. I know several thousand things that won't work. Thomas A. Edison. Content of the results. So now we come to the core of the paper, the data. This part of the paper is called the results section. Contrary to popular belief, you shouldn't start the results section by describing methods that you inadvertently omitted from the materials and methods section. There are usually two ingredients of the results section. First, you should give some kind of overall description of the experiment, providing the big picture without repeating the experimental details previously provided in materials and methods. Second, you should present the data. Your results should be presented in the past tense. See tense in scientific writing in chapter 30. Of course, it isn't quite that easy. How do you present the data? A simple transfer of data from laboratory notebook to manuscript will hardly do. Most importantly, in the manuscript you should present representative data rather than endlessly repetitive data. The fact that you could perform the same experiment 100 times without significant divergence in results might be of considerable interest to your major professor, but editors, not to mention readers, prefer a little bit of predigestion. Aronson, 1977, p. 10, said it another way. The compulsion to include everything, leaving nothing out, does not prove that one has unlimited information. It proves that one lacks discrimination. Exactly the same concept, and it is an important one, was stated almost a century earlier by John Wesley Powell, a geologist who served as president of the American Association for the Advancement of Science in 1888. In Powell's words, the fool collects facts, the wise man selects them. How to handle numbers if one or only a few determinations are to be presented. They should be treated descriptively in the text. Repetitive determinations should be given in tables or graphs. Any determinations, repetitive or otherwise, should be meaningful. Suppose that, in a particular group of experiments, a number of variables were tested, one at a time. Of course, those variables that affect the reaction become determinations or data and, if extensive, are tabulated or graphed. Those variables that do not seem to affect the reaction need not be tabulated or presented. However, it is often important to define even the negative aspects of your experiments. It is often good insurance to state what you did not find under the conditions of your experiments. Someone else very likely may find different results under different conditions. If statistics are used to describe the results, they should be meaningful statistics. Erwin Netter, who was editor-in-chief of Infection and Immunity, told a classic story to emphasize this point. He referred to a paper that reputedly read, 33 1/3% of the mice used in this experiment were cured by the test drug. 33 1/3% of the test population were unaffected by the drug and remained in a moribund condition. The third mouse got away. Strive for clarity. The results should be short and sweet, without verbiage. Mitchell, 1968, quoted Einstein as having said, "If you are out to describe the true elegance to the tailor, although the results section is the most important part, It is often the shortest, particularly if it is preceded by a well-written materials and methods section and followed by a well-written discussion. The results need to be clearly and simply stated because it is the results that constitute the new knowledge that you are contributing to the world. The earlier parts of the paper, introduction, materials and methods, are designed to tell why and how you got the results. The later part of the paper, discussion, is designed to tell what they mean. Obviously, therefore, the whole paper must stand or fall on the basis of the results. Thus, the results must be presented with crystal clarity. Avoid redundancy. Do not be guilty of redundancy in the results. The most common fault is the repetition in words of what is already apparent to the reader from examining the figures and tables. Even worse is the actual presentation, in the text, of all or many of the data shown in the tables or figures. This grave sin is committed so frequently that it is commented on at length, with examples, in the chapters on how to prepare tables and illustrations, chapters 16 and 17. Do not be verbose in citing figures and tables. Do not say, "It is clearly page 7 shown in table 1 that no-cilling inhibited the growth of gonorrhea." Say, "No-cilling inhibited the growth of gonorrhea, table 1. The latter format has multiple benefits. Because it is briefer, it helps authors comply with journals' word limits. It also is more readable. It also directs attention to what is most important. The findings, not the table or figure." Some writers go too far in avoiding verbiage, however. Such writers often fail to provide clear antecedents for pronouns, especially at, "Here is an item from a medical manuscript. The left leg became numb at times and she walked it off. On her second day, the knee was better, and on the third day it had completely disappeared." The antecedent for both is presumably the numbness, but the wording in both instances seems a result of dumbness. A supplement on supplementary material online. Increasingly, journals are electronically posting material supplementary to papers being published. Although sometimes this material regards methods, most commonly it provides information about the results. For example, additional data may be posted, or additional tables and figures may be provided online. Whether authors may submit such supplementary material, and if so how, varies among journals. Also, norms regarding what supplementary materials to provide online vary among research fields. If you think that providing supplementary material for online posting would be desirable, consult the instructions to authors of your target journal. If possible, also see what papers analogous to yours have done in this regard. Keep in mind, too, that the journal editor may ask you to place some of your material in an online supplement. 6. How to design effective tables. A tabular presentation of data is often the heart or, better, the brain of a scientific paper. Peter Morgan would to use tables. Before proceeding to the how-to of tables, let us first examine the question of whether to. As a rule, do not construct a table unless repetitive data must be presented. There are 2 reasons for this general rule. First, it is simply not good science to regurgitate reams of data just because you have them in your laboratory notebooks. Only samples and breakpoints need be given. Second, the cost of publishing tables can be high compared with that of text, and all of us involved with the generation and publication of scientific literature should worry about the cost. If you made, or need to present, only a few determinations, give the data in the text. Tables 16.1 and 16.2 are useless, yet they are typical of many tables are submitted to journals. Table 16.1 is faulty because 2 of the columns give standard conditions, not variables and not data. If temperature is a variable in the experiments, it can have its column, if all experiments were done at the same temperature. However, This single bit of information should be noted in the materials and methods section and perhaps as a footnote to the table, but not in a column in the table. The data presented in the table can be given in the text itself in a form that is readily comprehensible to the reader, without taking up space with the table. Very simply, these results would read: aeration of the growth medium was essential for the growth of Streptomyces coli color. At room temperature, 24 degrees Celsius, no growth was evident in stationary, unaerated cultures, whereas substantial growth, odd, 78 clet units, occurred in shaken cultures. Table 16.1, Effect of aeration on growth of Streptomyces coli color temp, degree Celsius, no. Of expiration of growth medium growth 24-24-78 is determined by optical density, clet unit. Symbols, plus. 500 milliliter Erlenmeyer flasks were aerated by having a graduate students blow into the bottles for 15 minutes out of each hour, identical test conditions, except that the aeration was provided by an elderly professor. Table 16.2, Effect of temperature on growth of oak, quercus, seedling stem, degree Celsius growth in 48 hours, -50 -40 -30 80 90 100 How to write and publish as each individual seedling was maintained in an individual round pot, 10 centimeters in diameter and 100 centimeters high, in a rich growth medium containing 50% Michigan peat and 50% dried horse manure. Actually, it wasn't 50% Michigan, the peat was 100% Michigan, all of it coming from that state. And the manure wasn't half dried, 50%, it was all dried. And, come to think about it, I should have said 50% dried manure, horse. I didn't dry the horse at all. Table 16.2 has no columns of identical readings, and it looks like a good table. But is it? The independent variable column, temperature, looks reasonable enough. But the dependent variable column, growth, is a suspicious number of zeros. You should question any table with a large number of zeros, whatever the unit of measurement, or a large number of 100s when percentages are used. Table 16.2 is a useless table because all it tells us is that the oak seedlings grew at temperatures between 20 and 40 degrees Celsius. No measurable growth occurred at temperatures below 20 degrees Celsius or above 40 degrees Celsius. In addition to zeros and 100s, be suspicious of plus and minus signs. Table 16.3 is of a type that often appears in print. Although it is obviously not very informative, all this table tells us is that S. griseus, S. coli color, S. every color, and S. rainbowski grew under aerobic conditions, whereas S. not color and S. greenicus required anaerobic conditions. Whenever a table, or columns within a table, can be readily put into words, do it. Some authors believe that all numerical data must be put in a table. Table 16.4 is a sad example. It gets sadder when we learn, at the end of the footnote, that the results were not statistically significant anyway, p equals 0.21. If these data were worth publishing, which seems doubtful, one sentence in the results would have done the job. The difference between the failure rates 14%, 5 of 35, for nosylene and 26%, 9 of 34, for potassium penicillin V was not significant, p equals 0.21. Table 16.3, Oxygen requirement of various species of Streptomyces organism growth under aerobic conditions. Anaerobic conditions. Streptomyces griseus S. coli color S. not color S. every color S. Greenicus rainbowski +++++1+1 see Table 16.1 for explanation of symbols. In this experiment, the cultures were aerated by a shaking machine. New Brunswick Shaking Company, Scientific New Jersey, 4. Bacteriological failure rates NASA link penicillin 535, 14934, 26. Results expressed as number of failures/total, which is then converted to a percentage, within parentheses. P equals 0.21. Table 16.5. Adverse effects of niclosilin in 24 adult patients. No. Of patients side effect diarrhea, eosinophilia, 25 eos/m, metallic taste, yeast, vaginitis, mild rise in urea, nitrogen, hematuria, 8 to 10 RBC/HPF. Both of the patients who tasted metallic worked in a zinc min. E. The infecting organism was a rare strain of Candida albicans that causes vaginitis in yeasts but not in humans. In presenting numbers, give only significant figures. Non-significant figures may mislead the reader by creating a false sense of precision. They also make comparison of the data more difficult. Unessential data, such as laboratory numbers, results of simple calculations, and columns that show no significant variations, should be omitted. Another very common but often useless table is the word list. Such a list might be suitable for a slide in a presentation, but it does not belong in a scientific paper. Table 16,5 is an example. This information could easily be presented in the text. A good copy editor will kill this kind of table and incorporate the data into the text. Yet, when copy editors do so, and this leads to the next rule about tables, they often find that much or all of the information was already in the text. Thus, the rule, present the data in the text, or in a table, or in a figure, never present the same data in more than one way. Of course, selected data can be singled out for discussion in the text. Tables 16,1 to 16.5 provide typical examples of the kinds of material that should not be tabulated. Now let us look at material that should be tabulated. How to arrange tabular material. Having decided to tabulate, you ask yourself the question, how do I arrange the data? Since a table has both left-right and up-down dimensions, you have two choices. The data can be presented either horizontally or vertically, but can does not mean should. The data should be organized so that the like elements read down, not across. Examine tables 16.6 and 16.7. They are equivalent, except that table 16.6 reads across, whereas table 16.7 reads down. To use an old-fashioned expression, table 16.6 is backward. Table 16.7 is the preferred format because it allows the reader to grasp the information more easily, and it is more compact and thus less expensive to print. The point about ease for the reader would seem to be obvious. Did you ever try to add numbers that were listed horizontally rather than vertically? The point about reduced printing costs refers to the fact that all columns must be wide or deep in the across arrangement because of the diversity of elements, whereas some columns, especially those with numbers, can be narrow without runovers in the down arrangement. Thus, table 16.7 appears to be smaller than table 16.6, although it contains the same information. 6. Characteristics of antibiotic-producing streptomyces. Determination where the flying fishes play. Color of mycelium. Antibiotic-produced yield of antibiotic, mg/ml. Optimal growth temp, degrees Celsius. S. Flora color 4108-10 pronounced strongly by the British. 4108 Dan S. Crassus. Coeli color 24 gray 78-28 Na color fluoracillin mycin streptomycin roll monoleanomycin red 2. Table 16.7. Characteristics of antibiotic-producing streptomyces. Optimal growth color of mycelium organism. Antibiotic-produced temp, degrees Celsius -10 Flora color 10 fluoracillin mycin S. griseus gray streptomycin red roll mondale, coli colorescent color purple no mycin purple yield of antibiotic, mg/ml. 4192 co-words in the column are lined up on the left. Numbers are lined up on the right, or on the decimal point. Table 16, 7, for example, illustrates this point. Table 16.8 is an example of a well-constructed table. It reads down, not across. Its title and headings are clear enough for readers to understand the data without referring to the text. Items in the body of the table appear in a logical order. The footnote provides supplementary information on how the data were obtained rather than repeating excessive methodological detail. Table 16.8, Hospitalizations and total charges for neglected tropical diseases and malaria, United States, 2003 to 2012 hospitalizations total charges US, no. Disease 95% C millions 95% C, SESE, cysticercosis 23, 266 degrees 21,741 to 24,792, 778 56 387 malaria 351 423. 434 18 206 echinococosis 3,9 19 3586 to 4,252 174 to 237 170 16 soil transmitted helminth associated 3,256 201 151 degree 2959 3 552 infections 19 162, 239 dengue 89, 135 70 to 107 leprosy 2,055, 135, 1,791 to 2,31976 to 111 lymphatic filariasis 1,836, 106, 1,629 to 2,044 9 schistosomiasis 1,811, 120, 1,576 to 2,046 1278 to 125 Chagas disease 1, 686,118, 151, 1,389 to 1,982 1784 to 152 Leishmaniasis 1,022 92 841 to 1,203 7 38 to 66 14,319 13,469 to 15,169 2 644 2279 minus 2,909 1,149 10 1.039 to 1,259 68 to 103 8 is an example of a well-constructed table. It reads down, not across. Its title and headings are clear enough for readers to understand the data without referring to the text. Items in the body of the table appear in a logical order. The footnote provides supplementary information on how the data were obtained rather than repeating excessive methodological detail. Table 16.8, Hospitalizations and total charges for neglected tropical diseases and malaria, United States, 2003 to 2012 hospitalizations total charges disease US dollar, no. Millions 95% CSE cysticercosis 23,266 minus 1, 1491,039 to 1,259 malaria 14,31938 7 Leishmaniasis schistosomiasis trachoma Chagas disease leprosy lymphatic filariasis echinococosis soil transmitted helminth associated infections dengue 3 919, 106, SE, 1022, 92 649, 69, 120, 1686, 151, 678, 21,741 to 24,792, 3,256, 151,836, 434, 13,469 to 15,169, 2,055, 135, 2,644, 135, 1.811, 170, 3,500 to 4,252, 2,379 to 2,909, 1,791 to 2,319, 514 to 784, 841 to 1. 203.95% C 1.389 to 1,982, 2,959 to 3,552, 3.586 to 4,252, 1,029 to 2,044, 1,576 to 046, 56, 9 101, 12, 16, 201, 19, 118, 17, 52, 18, 206, 20, 351 to 423, 68 to 103, 78 to 125, 174 to 237, 84 to 152, 76 to 111, 162 to 239, 38 to 66, 70 to 107, 610, 60, 10492. 7 to 9 exponents and table headings: foodborne Trematodes aided infections onchocerciasis UAS 28 384 7 161 287 473 106 216 12 29 7 2 28 to 54, 5 to 53, 3 to 11. National estimates were determined on the nationwide inpatient sample by using diagnostic codes from the International Classification of Diseases, 9th revision, clinical modification. A complete list of ICD-9 CM codes used in this study is provided in the online technical appendix, www.nc, CDC. gov/ed/article/21/6/141324 TechHack1. PDF. Source: O'Neill S.A., Flecker R.H. Hospitalization frequency and charges for neurocysticercosis, United States, 2003 to 2012. EMERG. Infect. Dis. 21 to 969,976, 2015. Available at http://www.nc, CDC. gov/ed/article/21/6/PDFs/141324. PDF. Access to August 27, 2015. Note that these tables have 3 horizontal rules, lines, but no vertical rules. Virtually all tables are constructed this way. Occasionally, straddle rules, as below hospitalizations and total charges in Table 16.8, are used. Vertical rules normally are not used in tables. 41.7. If possible, avoid using exponents in table headings. Confusion has resulted because some journals use positive exponents and some use negative exponents to mean the same thing. For example, some have used CPMX 102 to refer to thousands of counts per minute, whereas others have used CPMX 10 to 2 for the same thousands of counts. If it is not possible to avoid such labels in table headings, or in figures, it may be worthwhile to state in a footnote, or in the figure legend, in words that eliminate the ambiguity, what convention is being used. Following the journal's instructions to authors commonly include a section about tables. Before preparing your tables, check the instructions to authors of your target journal. These instructions may indicate such items as the dimensions of the space available, the symbols or form of lettering for indicating footnotes to tables, and the electronic tools to use in preparing tables. Looking at tables in the journal as examples also can aid in preparing suitable tables. Style manuals in the sciences provide guidance in preparing not only text but also tables and figures. If your target journal specifies a style manual that it follows, consult it in this regard. Even if the journal does not specify a style manual, looking at one relevant to your field can aid in preparing effective tables and figures. Traditionally, journals have asked authors to submit each table on a separate page at the end of the text. In addition, some journals have said to identify in the margin of the text the first mention of each table, for example, by writing Table 3 and circling it. This procedure helps ensure that the author has indeed cited each table in the text, in numerical order. It also indicates to the compositor, at the page makeup stage, where to break the text to insert the tables. Today, some journals ask authors to embed tables in the text near their first mention, and some journals ask authors to submit tables as separate files, to determine whether tables should be placed within the text, placed at the end, or provided in separate files, and to determine how, if requested, to indicate their placement. Consult the instructions to authors. Titles, footnotes, and abbreviations. The title of the table, or the legend of a figure, is like the title of the paper itself. That is, the title or legend should be concise and not divided into two or more clauses or sentences. Unnecessary words should be omitted. Give careful thought to the footnotes to your tables. If abbreviations must be defined, you often can give all or most of the definitions in the first table. Then later tables can carry the simple footnote, abbreviations as in Table 1. Note that tables 16.1, 16.2, 16.6, and 16.7 is used as an abbreviation for temperature, because of space limitations in tables. Almost all journals encourage abbreviation of certain words and tables that would not be abbreviated in the text. Capitalize any such abbreviations used as the first word in a column heading. Do not use periods, except after no, which might be misread without the period. To identify abbreviations that your target journal considers acceptable in tables, you can look at tables published in the journal. Also, some journals list in their instructions to authors the abbreviations that can be used without definition in tables that they publish. Additional tips on tables. The following are some further tips to help ensure that you design and use tables effectively. Use wording that will be clear without reference to the text. For example, a table should not just refer to Group 1 and Group 2. Rather, it should identify each group by a more meaningful designation. Examples: high-dose group and low-dose group, REM sleep group and an REM sleep group, and graduate students and professors. If a paper includes a series of tables presenting analogous data, use an analogous format for each. For example, if several tables compare the same four groups from different standpoints, list the four groups in the same order in each table. Or if different tables present data on the same variables at different times, keep listing the variables in the same order. Such consistency saves readers effort, and it is easier for you, too. Finally, remember to mention every table in the text. Do so as soon as readers are likely to want to see the table. You have gone to the effort of preparing good tables. Be sure that readers can benefit fully from them. 7. How to prepare effective graphs. A good illustration can help the scientist to be heard when speaking, to be read when writing. It can help in the sharing of information with other scientists. It can help to convince granting agencies to fund their research. It can help in the teaching of students. It can help to inform the public of the value of the work Mary Helen Briscoe when not to use graphs. In the previous chapter, we discussed certain types of data that should not be tabulated. They should not be turned into graphs either. Basically, graphs are pictorial tables. The point is this: certain types of data, particularly the sparse type or the type that is monotonously repetitive, do not need to be brought together in either a table or a graph. The facts are still the same. Preparing and printing an illustration can be time-consuming and expensive, and you should consider illustrating your data only if the result is a real service to the reader. This point bears repeating because many authors, especially those who are still beginners, think that a table, graph, or chart somehow adds importance to the data. Thus, in this search for credibility, there is a tendency to convert a few data elements into an impressive-looking graph or table. Don't do it. Your more experienced peers and most journal editors will not be fooled. They will soon deduce that, for example, 3 of the 4 curves in your graph are simply the standard conditions and that the meaning of the 4th curve could have been stated in just a few words. Attempts to dress up scientific data are usually doomed to failure. If there is only one curve on a proposed graph, can you describe it in words? Possibly only one value is really meaningful, either a maximum or a minimum. The rest is window dressing. If you determined, for example, that the optimum pH value for a particular reaction was pH 8.1, it would probably be sufficient to state something like, maximum yield was obtained at pH 8.1. If you determined that maximum growth of an organism occurred at 37 degrees Celsius, a simple statement to that effect is better economics and better science than a graph showing the same thing. 605 40 20 56 Total number of patients, number of infections, average number of days in hospital. Figure 17.1. Incidence of hospital-acquired infections. If the choice is not graph versus text but graph versus table, your choice might relate to whether you want to impart to readers exact numerical values or simply a picture of the trend or shape of the data. Rarely, there might be a reason to present the same data in both a table and a graph, the first presenting the exact values and the second showing a trend not otherwise apparent. Most editors would resist this obvious redundancy, however, unless the reason for it was compelling. An example of an unneeded bar graph is shown in Figure 17.1. This figure could be replaced by one sentence in the text. Among the test group of 56 patients who were hospitalized for an average of 14 days, 6 acquired infections. When is a graph justified? There are no clear rules, but let us examine some indications for their effective use. When to use graphs. Graphs resemble tables as a means of presenting data in an organized way. In fact, the results of many experiments can be presented either as tables or as graphs. How do we decide which is preferable? This is often a difficult decision. A good rule might be this: if the data show pronounced trends, making an interesting picture, use a graph. If the numbers just sit there, with no exciting trend in evidence, a table should be satisfactory and perhaps easier and cheaper for you to prepare. Tables are also preferred for presenting exact numbers. Table 17.1. Effect of streptomycin, isoniazid, and streptomycin plus isoniazid on Mycobacterium tuberculosis. Treatment percentage of negative cultures at 2 weeks, 4 weeks, 6 weeks, 8 weeks. Streptomycin, isoniazid, streptomycin plus isoniazid. 58 30 10 12 60 15 15 80 20 15 100. The patient population, now somewhat less so, was described in a preceding paper. 61. Highest quality available from our supplier, Town Pharmacy, Podunk, Iowa. Negative cultures, percent, 180 duration of treatment weeks 2. Effect of streptomycin, O, isoniazid, and streptomycin plus isoniazid, C, on Mycobacterium tuberculosis. Examine Table 17.1 and Figure 17.2, both of which record exactly the same data. Either format would be acceptable for publication, but Figure 17.2 clearly seems superior to Table 17.1. In the figure, the synergistic action of the two-drug combination is immediately apparent. Thus, the reader can quickly grasp the significance of the data. It also appears from the graph that streptomycin is more effective than is isoniazid, although its action is somewhat slower. This aspect of the results is not readily apparent from the table. How to prepare graphs. Early editions of this book included rather precise directions for using graph paper, India ink, lettering sets, and the like. Graphs had been prepared with these materials and by these techniques for generations. Today we prepare graphs by computer. However, the principles of producing good graphs have not changed. The sizes of the letters and symbols, for example, must be chosen so that the final published graph in the journal is clear and readable. The size of the lettering must be based on the anticipated reduction that will occur in the publishing process. This factor can be especially important if you are combining two or more graphs into a single illustration. Remember, text that is easy to read on a large computer screen may become illegible when reduced to the width of a journal column. Each graph should be as simple as possible. The most common disaster in illustrating is to include too much information in one figure. Too much information in an illustration confuses and discourages the viewer. Briscoe 1996. 3 is a nice graph. The lettering is large enough to read easily. It is boxed, rather than two-sided. Compare with Figure 17.2. Making it a bit easier to estimate the values on the right-hand side of the graph. The scribe marks point inward rather than outward. If your paper contains two or more graphs that are most meaningful when viewed together, consider grouping them in a single illustration. To maximize readability, place the graphs above and below each other rather than side by side. For example, in a two-column journal, placing 3 graphs in an above and below arrangement allows each graph to be 1 or 2 columns in width. If the graphs appear side by side, each can average only 1/3 of a page wide. Whether or not you group graphs in such a composite arrangement, be consistent from graph to graph. For example, if you are comparing interventions, keep using the same symbol for the same intervention. Also be consistent in other aspects of design. Both conceptually and aesthetically, the graphs in your paper should function as a set. Do not extend the ordinate or the abscissa, or the explanatory wording, beyond what the graph demands. For example, if your data points range between 0 and 78, your topmost index number should be 80. You might feel a tendency to extend the graph to 100, a nice round number. This urge is especially difficult to resist if the data points are percentages, for which the natural range is 0 to 100. Resist this urge, however. If you do not, parts of your graph will be empty. Worse, the live part of your graph will then be restricted in dimension. Because you have wasted perhaps 20% or more of the width, or height, with anti-white space. Percent of control 300.20.40.60 spermidine. mg/ml.801.00 Figure 17.3. Effect of spermidine on the transformation of B subtilis Br151. Competent cells were incubated for 40 minutes with spermidine prior to the addition of 5 micrograms of donor DNA per milliliter, or 0.5 micrograms of donor DNA per milliliter, A. DNA samples of 5 micrograms, or half a microgram per milliliter, A. were incubated for 20 minutes prior to the addition of cells. Redrawn from Figure 1 in Clark P.O. and Leach Father. Stimulation of Bacillus subtilis transformation by spermidine. Mole. General Genet. 178 21-25, 1980. Copyright by Springer Verlag 1980. With permission of Springer. 0-78. You're in the preceding example. Data points ranging from reference numbers should be 0, 20, 40, 60, and 80. You should use short index lines at each of these numbers and also add the intermediate one os, 10, 30, 50, 70. Obviously, a reference stub line halfway between 0 and 20 could only be 10. Thus, you need not letter the 10s, and you can then use larger lettering for the 20s, without squeezing. By using such techniques, you can make graphs simple and effective instead of cluttered and confusing. Symbols and legends. If there is a space in the graph itself, use it to present the key to the symbols. In the bar graph, figure 17.1, the shadings of the bars would have been a bit difficult to define in the legend, given as a key. They need no further definition, and any additional typesetting, proofreading, and expense are avoided. If you must define the symbols in the figure legend, you should use only those symbols that are considered standard and that are widely available. Perhaps the most standard symbols are open and closed circles, triangles, and squares. If you have just one curve, use open circles for the reference points. Use open triangles for the second, open squares for the third, closed circles for the fourth, and so on. If you need more symbols, you probably have too many curves for one graph, and you should consider dividing it into two. Different types of connecting lines, solid, dashed, can also be used. But do not use different types of connecting lines and different symbols. As to the legends, they should normally be provided on a separate page, not at the bottom or top of the illustrations themselves. The main reason is that two portions commonly are processed separately during journal production. Consult the instructions to authors of your target journal regarding this matter and other requirements for graphs. A few more tips on graphs. Design graphs, like tables, to be understandable without the text. For example, use meaningful designations, not just numbers, to identify groups, and refer to each graph as soon as readers are likely to want to see it. Do not leave readers trying to visualize your findings by sketching them on a napkin only to find 3 pages later that a graph displays them. Use graphs that depict your findings fairly and accurately. For example, do not adapt the scales on the axes to make your findings seem more striking than they are. With rare exceptions, avoid beginning a scale at anything other than 0. And if you interrupt a scale line to condense a graph, make the interruption obvious. Also, if the standard deviation is the appropriate way to show the variability in your data, do not substitute the standard error of the mean, which might make the data seem more consistent than it is. Note that some journals, mainly the larger and wealthier ones, redraw graphs and some other types of figures to suit their own format. Whether or not a journal will do so, prepare your graphs well. Doing so will help make your findings and their value clear and will help show the care with which you do your work.